Hi there, everyone. Well, let's see another example on how to determine the mean and variance of random variables. So the report of a weather bureau on the forecast of number of typhoons entering the country's area of responsibility is manifested to be the following probability distribution. So we have number of typhoons that may come up the next month, for example, and these are the probabilities of these number of typhoons coming up. So how can we interpret this? That um, the probability that zero typhoon comes in the Philippines is 15%. The probability that one typhoon will come is 35%. Probability of two typhoons is 30%, and so on. So we want to answer the problems or the questions. What is the average number of typhoons entering the country per month? And what is the standard deviation? So recall the formula for the mean is like this. So first we want to get the product of each column or each x and p of x, then you sum them up. Okay, and our shortcut formula for the variance is this. So we square the random variables, just multiply that then by its probability, we sum up those products, and then ultimately we deduct that, we subtract that by the mean squared. So let's have that. First thing that we need to do is we multiply each of them per column this time. Our previous example is per row. Anyhow, it doesn't matter. The thing is you can understand how to build them up. So 0 times 0.15 is 0. Um, 1 times 0.35 is 0.35, 0.35. 2 times 0.03 is 0.6. 10 or 3 times 0.01 is 0.3. And 4 times 0.10 is 0.4. We will sum them up so we can see the common 10. The answer is 1.65, right? So just simply sum it up, 1.65. So on average, how many typhoons can we expect in a given month? If the answer is 1.65. So if you're going to round that up, it's more likely to be 2, right? So it's inclining to be 2. So the probability that we will get what's the expected number or the mean value or the mean number of typhoons we were expecting every month, it's going to be 2. Okay, and how about the standard deviation or the deviation of this number? So first thing that we need to do is we need to square each of the x's. 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, and 4 squared is 16. Then we multiply them each to the random variable, or to the probability that it has. This becomes 0. Remember, this is x squared times times your p. X squared times p of x. Okay. Okay, so 1 times 0.35 is 0.35. 0.3 times 4, it's going to give us 1.2. 9 times 0.01 is 0.9. 16 times 0.01 is 1.6. And then ultimately, we're going to sum them up. What's the sum, by the way? So 1.55, and then add that 0.9. It's going to be 2.4 times 1.6. It's going to be 3, right? So 0.35 times 1.2, it's going to be 1.55. 1.55 plus 0.9, it's going to be 2.45. 2.45 plus 1.6, it's going to be 4.05. Okay, and 4.05, we minus that to the square of the mean, which is 1.65. 4.05, let's try that, sorry. So 4.05, we multiply that by the square of the mean, which is, what's that again? 1.65. So 1.65 quantity squared. It's gonna give us 1.3 275. Let's round it up to the second decimal place, 1.33. So the variance we have is 1.33. But take note, the variance is not what is asked here, but it's a standard deviation. What we need to do is we need to get the root or the square root of this. It's going to be 1.15. Okay, 1.15. So the standard deviation is 1.15, meaning our sigma or our mu, our mean is 1.6. You add minus 1.15 there. So it's going to be the value here would be 1.65 minus 1.15, and these are the intervals, 1.65 plus 1.15. If these are the intervals, we are expecting, these are the interval numbers we're expecting 68% of the time, the number of typhoons will enter these numbers. So it's from 0.5 to the next one to 2.8. So you're expecting 68% of the time it will be like that. Okay. Now to end this video, just like to recall Bernoulli trials or binomial distribution. If you are sure that you're doing a Bernoulli process, that is a random variable generated is what we call a Bernoulli random variable or a binomial distribution, there's a shortcut to get the mean and variance. Simply to get the expected value, you just need to multiply the number of trials n times the probability of success p. And if you want to get the variance or sigma squared, it's just multiply n times p times q. And multiply the number of trials n times the probability of success p times the probability of failure f. Or sorry, q. So that's how we get the mean and variance of binomial distributions. Note that this is only for the Bernoulli random variables. So if we're going to see some examples, say the experiment consists of repeated trials, and in each trial there is an outcome that is classified as success and failure, and the probability of success p remains constant from each trial because they are independent of one another, so it doesn't change. So this is the one, Johan, oh sorry, Jax, in some books Jacob, in some books James. It has a lot of he has a lot of names. Not really sure what it is, what's the true one, but this is the Bernoulli that discovered the Bernoulli random variables. Okay, so for example, if we're gonna be given this kind of value, construct a probability distribution table of tossing a balance coin 3 times. So our n is 3. The mean value when you toss a coin, the success is 1/2. Say we are interested in getting the heads. So what is the expected value of heads that we can get? So the mean is the probability of success is 1/2. 1/2 times 3 is 1.5. So that's our standard deviation. That's our expected value. So in 3 tosses, you're gonna get 1.5 heads more or less. The SD is you multiply that by another 1/2. So 1.5 times 1/2. You just divide that to 0.75. To get the standard deviation, you get the square root of that, which is 0.86 or 87. Okay, so that's it for the mean and variance of random variables and of course for the binomial distribution. We will be ending our lessons here, I suppose, in Poisson probability distributions, which is an approximation of the binomial process, okay, as n goes to infinity. So anyhow, thank you for watching and see you in the next video. Goodbye.